Alright guys, this video is going to be talking about um, what you need to do in order to get your mobile power needs met for your robot for the STEM robotics competition. And we're going to be discussing how to create your power hookups for both your Raspberry Pi and your Hatboard. Uh, you should have already watched the power demands video previously. This is going to be a step-by-step video on how to make some of those connections talked about in the previous video. So the first thing you're going to need to do is go ahead and gather the following items. You're going to need a soldering iron, a set of wire strippers, a Phillips head screwdriver, and not pictured here, you will need a set of needle nose pliers. Now, we're first going to discuss what you're going to need to put together your power hookups for the Hatboard. And to do this, you're going to need a set of female disconnects to allow you to hook up to your battery. You're going to need your Hatboard. You're going to need this device here. It's called a DC to DC converter, but you're going to hear me call it a buck converter. But essentially this is just a DC to DC converter. That's this nifty little device here. And you're going to need a couple of header pins. Now, I've already described in the previous video what this buck converter does, but just to give you a general idea of what you're going to be making in order to power your Hatboard, this is a picture of essentially what this buck converter is going to need to look like when you're done. And really, only thing we're doing for this particular connector is just adding a couple of female disconnects. And you know, it's pretty straightforward for this connection. To do this, you're going to need some wire strippers, and if you're not aware, you know, on almost any set of wire strippers, and these are two different styles, you have an area that's designed specifically to crimp those quick disconnects, the female disconnects. If your wire strippers look like this, you know, that area for crimping is going to be down here. If yours look like this, it's this area up here. And you know, on this style of wire strippers, this area is used for actually stripping the wire, and on this style, the wire is stripped up here. So go ahead and grab one of your female disconnects, and you're going to take the disconnect and you're going to slide it over the wire. Now, it's good practice to, you know, adhere to the color code of your wire. So we're going to use a red female disconnect to attach it to our red positive 5-volt wire. You know, one thing you may want to do is, even though the output end of these wires come pre-stripped, you may want to take your wire strippers and remove a little bit more of that insulator, a little bit more of that coating, to expose a little bit more wire. This will basically help get you a better connection if you don't have a whole lot of wire exposed here. So you slide this connector over your wire, and basically what will happen is your wire is going to exist in this area here. And go ahead and take your wire strippers and crimp it, and it should be squeezed tight enough to where the metal that's inside of this female disconnect gets crushed to the point where it's making good contact with the wire that's going through here. Once you've done this, if you can tug on that wire and your wire slips out, your connection's not good enough and needs to be redone. You know, power is critical for this year's competition, and if you have loose connections, it's going to present a ton of problems for you down the road. So go ahead and get this right and make sure you have a good solid connection with these female disconnects and your power input wires of your buck connector. You're going to go ahead and repeat those same steps for the negative wire. And as you can see here, I'm not going to go over it, but it's the same thing. Have that wire stripped off, put your female disconnect on there. Notice we used a black wire, and we used a black female disconnect. This is just to help color code us, so when we go to hook up the battery, we don't make mistakes and put, positive to negative and negative to positive. We wouldn't want to do that. So, once you have these disconnects done, you should be able to connect it up to one of your batteries fairly easily. These female disconnects slide right onto those battery terminals. And like I said, your red lead is positive and your black lead is negative. So positive to positive, negative to negative, and it's pretty straightforward. And, if you're still not quite sure what this is doing, we're taking our 12 volts from our battery, and this little circuit here is essentially stepping that down to give us 5 volts output here. Once you've created your buck converter for your hat board, you're going to want to go ahead and grab your hat board. Now, if you take a look at the hat board, there's two places that we can power the hat board from. And the first place is this DC power connector. And we're not going to be using that because we don't have the correct jack to plug directly into there. We're actually going to be using this power terminal block right next to it, and this power terminal block has two little screws in it that we can connect wires to, positive and negative, or positive and ground wires to, in order to power up our hat board, and that's what we're going to be doing here. Now, if we wanted to, we could cut the end of this socket off and tin the wires and plug those into the power block directly, but because the gauge of this wire is so small, even when they're tinned, they have a hard time staying in place, and they tend to break. So what we're going to do is actually use a couple of header pins, and we're going to tighten those down inside the power terminal block, and we're actually going to plug this end directly into the power terminal block itself. It gives us a nice solid connection, and you'll see how we do that. So, in order to make this connection happen, you're going to need to grab some header pins. You really only need two, but it's easier to get to by taking the whole row and getting your needle nose pliers and just give a tug on one of those pins, and it'll actually come right out. And as you can see here, I've removed this header pin from this plastic, and this is what we're actually going to be using, the header pin that's right here. And we need to do this twice because we need two of them. And once we've gotten one of those header pins, we're going to take it and slide it into our power terminal block, and we're going to grab our Phillips head screwdriver and we're going to tighten it down. And once you've tightened it all the way down, this pin should basically stay put. It should not move at all. It's wide enough and thick enough to where this power terminal block can grab a hold of it pretty well, and it provides a very stable connection. We're going to do that twice. So in this picture you can see we've taken both of our header pins and we've put them into our power terminal block, tighten them down nice and tight, and we're good to go ahead and plug in our buck converter from our battery right to our hat board. Now, the one thing I want to point out is making sure we align the correct wires. So as you can see, our black wire, our negative or ground, is connected to the pin that's labeled ground, and our red wire, our positive 5 volts, is connected to the pin that's labeled positive 5 volts. If you connect these up the wrong way, you're going to create some issues for yourself. So make sure you plug this in correctly. And if you take an even closer look, you'll see that there's actually an empty socket here. You don't even need to worry about that, okay? As long as you have those pins connected to the correct associated socket with your wire, you should be fine. And you know you did this correctly if your power indicator light comes on your hat board and is green when you have it hooked up to both the battery power and to the hat board. What we're going to be talking about now is how to prepare your buck converter, and again that's this thing here, for use with the Raspberry Pi. And it's a little bit different because the Raspberry Pi requires a micro USB to power it up, and we have to essentially make this. So we're going to go through this step by step. And before we do that, you can go ahead and add 2 female disconnects to the input side of that buck converter, just like we did for the hat board. It's the same thing. I'm not going to go over it again. It's the same set of steps. Just make sure you put those female disconnects on the same input side of your buck converter. And what we need to do to make this one work for the Raspberry Pi has to do with what goes on down here. So stay tuned and just be aware. All this is the same. You can repeat those same set of steps to add your female disconnects, and we're going to go ahead and move on to what we need to do to the output side of this buck converter. So the first thing you need to do is go ahead and cut this plug off. It's not going to work for us, okay? We have, 5 volts coming out here, and this isn't the correct kind of connector we need to run our Raspberry Pi. So go ahead and cut that off. As you can see here, we've removed it. You're then going to go ahead and strip those wires, okay? And grab a hold of it with the smallest hole on your wire stripper side, and go ahead and remove the insulator from your wires and get them cleaned off, as you can see in this picture. We've got a good bit of wire exposed, and then you're going to want to take those wires and twist them together, because they are a braided wire, just to get them connected so you don't have any wire strands or frays sticking out. It's going to make hooking these up to your micro USB a lot easier. So just grab the ends of those wires and give them a quick twist, and then you're ready to move on. So once those wires have been twisted together, you need to find your micro USB DIY kit, and inside this kit there are 4 pieces. There's the actual male micro USB plug, and then there's these 3 other components that are all part of the housing, okay, that make this look nice and neat and pretty when you're all done. So to get this set up, first thing you're going to need to do is take that big section of housing and slide it over your wires. If you don't do this first before you make your connection, you're not going to be able to get it on without unsoldering the plug. So go ahead and slide this housing block over your wires, and you can just slide it down. You can slide it all the way down the wire, even down to here, just to get it out of your way. You're then going to take this second little piece of the housing, looks like a little tube, and what this does is keeps the wires nice and tight, and this will actually stick out of the end of this housing when it's all said and done. You may have to press it down in there, but it keeps the wires grouped together. You can go ahead and put that on there, and again, you can slide both of these way down out of the way if you want. And then it's time to get ourselves ready to solder. Now, before we jump right in and solder this male USB plug on, I want to point out a couple of things. So, if you're looking at your micro USB plug, you'll notice that, on one side we have 3 contact points, and on the other side there's only 2. Now, there are 5 places total, 3 on this side and 2 on this side, that we could solder to. We only need to solder to 2, and that's the contact points or pins that are going to provide our power. Okay, so we need 5 volts to our Raspberry Pi, and only 2 of these pins go to the correct location to provide power. The other 3 are for data exchange, and we need to make sure we're soldering our wires to the correct pins. Now, the side we're concerned with is the side that has 3 pins on it, and the far left pin, if you're looking at your micro USB in this orientation, okay, so if you're looking at your micro USB and the actual male plug portion is facing this way and the bottom's here, this would be your negative wire, and this, we have to solder our negative wire to this contact point to provide ground to the Raspberry Pi, and we have to solder our 5-volt positive wire to this contact point. Now, this is a difficult soldering job. Okay, 100% it's a difficult soldering job. So you may want to consult your instructor when you're doing this, because it's absolutely critical to the success of your Raspberry Pi. So when you go to make this solder connection, I strongly encourage, if you have them, getting a set of helping hands, which are these things here. They look like, you know, little alligator clips, but I'm just using this to hold our wire in place, and this is going to make your life a whole lot easier if you can set up your micro USB and your wires in a set of helping hands. And the best thing to do is to get that wire and your micro USB so that wire's laying right on top of the contact point that you need to solder to. If you have to hold this in place with your hands, you're going to have a lot of trouble keeping it steady to actually make that solder connection. So once it's laid over that contact point and it's where it needs to go, go ahead and get your soldering iron, tin the tip of the iron, put a little solder on there, and go ahead and make that solder connection. You know, as you can see here. Now these are surface mounted, and once you make this solder connection, if you give a light tug, and I wouldn't pull too hard because these wires are thin, but if this becomes disconnected, you don't have good contact. It's absolutely critical that you have a solid contact here with this wire. You can do the same thing with the positive wire on the positive contact point. And one thing I want to point out is, after these solder connections are done, if you have a bunch of exposed wire that's not on the contact point, and it's possible for these wires to touch each other, you may want to go ahead and wrap a little piece of electrical tape or something in there to prevent these 2 wires from touching when you slide it inside the housing, because that's going to, you know, create a short, and it's going to mess up your power needs. Once you have those connections made, you're going to slide the male USB plug into the housing, as you can see here, or you can slide the housing up to the male USB. And you're going to take this final piece that's in your kit, and it slides over the end of that plug, as you can see here. And if you push down, it'll actually clip into place. Okay? And that'll give you a nice tidy micro USB connection on those wires. Now, when you go and test this to see if all of your connections are good, I strongly encourage removing your SD card before you ever plug this in. Now, only do this if your Raspberry Pi was properly shut down the last time it was used. If for some reason you have poor power connections here, and you're leaving your micro SD card, which is that thing here, connected to your Pi, and you plug this in and there's a loose connection, and you don't have a stable current going to your Pi, what you're actually doing is, turning it on and turning it off a bunch of times if you have a loose connection, and if your micro SD card is plugged in, which holds your operating system for your Raspberry Pi, essentially you're crashing your Pi over and over and over again. So once you have this buck converter created, test it to make sure you're getting a stable power connection without this inside of it. Once you're confident in your plug's ability to supply stable power to your Raspberry Pi, then you can think about putting your SD card in there and booting it up, and plugging your monitor, keyboard, mouse, and everything else you need to run this on your robot. And essentially that's it.